Alright, welcome to another episode of How Do We Pass Our Common Core Algebra Regions. So in this episode, we are going to cover everything that has to do with quadratics, or at least I'm going to try to cover everything from graphing quadratic equations to graphing quadratic functions to solving quadratic equations using all the different types of methods, okay? So let's see how it goes. Remember, I don't have the answers in front of me, so if I make mistakes, forgive me. Alright, so the first thing we're going to do is we're going to graph the function or the equation y equals to 3x squared. Now in this case I am not going to create a table of values, which it's not a bad idea. In this case I am going to first use the graphing calculator. So let me zoom out, okay? Hopefully you can see this, but no, okay. So the function is 3x to the second power. So what I'm going to do is, well, you don't need to know where the 3 is. Everybody knows where the 3 is on the calculator. I'm going to turn it on. I'm going to clear. I'm going to go to y equals. Okay. I'm going to clear this. And now I am going to press the following keys. So 3. Okay. 3. And then the x is right here next to the alpha key. 3x. Okay. And for the purposes being, okay, you could either press this button right here. Okay. That has the square root in blue. I'm going to zoom in. Okay, you could use that, or you could just press this key, which means anything to the whatever power. So I'm gonna press this button right here. Okay, so look, 3x squared. That's it. Now, yes, you wanna look what the graph look. You wanna know what the graph looks like. So that's what it looks like. It's a parabola. Every equation that has the maximum exponent as a 2 is a quadratic function, okay? Anything that has x squared as the maximum exponent is the quadratic function. All right, so you have the shape of the graph, but you need to know what the table of values is. So second graph. Good, we have values. Now, for the purposes being, let's take a look at what our graph, the numbers in our graph are. So you could see. All right, so you see that it doesn't have much on the positive side, but it has a lot on the negative side. All right, so that's what we're gonna graph. We have on the top, we have all the way to 12, so we're gonna graph values within that range. So let's see now. I cannot graph -7. I cannot graph that. Let me see. It looks like this. So we're going to graph. Okay, good. -2, 12. That's a good value, okay? So we're gonna go, we already went through how to graph. So -2, okay, 12. Actually, let me put the other pairs here. -2, 12. -1, sorry, -1, 3. 0, 0. 1, 3. 2, 12. Cannot graph 3. So we're gonna stop right there. Oh, okay, so now that I have this, I'm gonna zoom in so I could have a better view of the graph. All right, -2, 12, -1, 2, 12. So I'm gonna go all the way to 12. And I put my point in there. Let me see, maybe I should do a different one. Let's see what I have here. What do I have here? Good. Let me make this darker. So 12 right here. Okay, then I'm gonna graph -1, 3, -1, 3 right here. Then I'm gonna graph 0, 0. Then I'm gonna graph 1, 3. 1, 3. Look, that's it. Once the y values start repeating, then we know which one is the next one. The next one is gonna be 2, 12. Correct? Okay then. So this is what our parabola should look like, and this is the shape of it, the U, so you should know. So remember, you're not tracing straight lines like that, okay? It's a curve. So as bad as it seems, it's always a good idea to practice. So I'm gonna do this. That's one side of it. And now the other side. Let me see if it comes out good. Oh my God. Okay, so like that. Yes, it's not a perfect U like the one on the calculator, but it serves the purposes. All right, now let's study this function. There is something called the axis of symmetry. So we are going to explore that right away. The axis of symmetry, it's a line that divides the parabola in half. Well, where does a vertical line divide the parabola in half? Let's explore that. Let me get a ruler. I got a ruler. And time to explore. So watch this. The parabola gets chopped in half right here. See that? That's where the parabola gets chopped in half. So this blue vertical line is the axis of symmetry. Now it has an equation. There is an equation for that. And I'm going to tell you what it is. The equation will always look like x equal to a number. Well, what is that number? Remember, x equal to a number is a vertical line. So in this case, x is equal to 0. You see that? This is 0 for x. So then the axis of symmetry is 0. Now, this is called the axis of symmetry. AOS, axis of symmetry, is what divides the parabola in half. The other one is that you need to know the vertex. I need to put something here so I don't rip my table. Okay, now it should be better. Okay. So the AOS is 0. Now, there is also something called the vertex. What is the vertex? The vertex is the point where you can grab the parabola, okay, and turn it around, like if you had it in your hand. Another way of looking at it is that the vertex is the turning point where the y values start repeating. You see? 3, 3, 12, 12. So then, my axis of symmetry is obtained in the following way. You take your equation 3x squared, right? Y equals 3x squared. And you plug in the value that you found for the axis of symmetry. So then y equals to 3 times 0 squared. 0 squared is 0. 3 times 0 is 0. So the y value, when x is 0, the y value is also 0. But anyways, you could have just determined from the points that you have here. Okay? 0, 0, and then the values start repeating. So you know that this is the vertex. And always the x coordinate on the vertex is your axis of symmetry. Alright? Let's do another one, since we already covered that. Alright, how about this one? Let's see what this one looks like. So this one is negative x squared plus 2x plus 1. So I am going to take the calculator. Okay, I'm going to go to press y equals, and I am going to type, okay, I'm going to type that, exactly that. So clear this, and now we have negative x squared. Remember, press the negative on the calculator, not the minus, plus 2x plus 1. All right, we got that. Let's see what the behavior of the graph is. So press graph. Whoa. Now it's not going like a U, it's an upside down U. The parabola is concave down. It opens downwards. So why is that? Well, easy. Because the coefficient of x squared is negative. In other words, this is negative 1x squared. So that's why the parabola looks like that. All right, let's get our table of values. Let's copy and then let's do it. All right, so this one has values that increase by 0.5, 0, 0.5, 1, 1.5, 2. So something's gotta give. Now notice that on the calculator I don't have, okay, I don't have the values going by 0.5. So if you ever want to do something like that, you press the key that reads window. And if you want the y scale that says 1. That means go by ones. Well, you can make it 0.5. And now, when you do that, you go back to the table. The table will give you, wait, what did I do now? Window, 0.5, okay. It should have worked. 0.5. You know what? Let's make our x's go by 0.5 too. Let's see what's going on. See, maybe I got it wrong. Okay. The parabola still looks the same, and now I'm gonna go to the table. The table is not giving me anything. Something is not right. How do I set the table? Oh my God, look at this. It says table set. So I didn't even have to do that. Table 0.5. Now let's go to the table. That's what I wanted. That's what I needed to do. Well, good thing. Now we just figured it out. All right, so let me copy the values that I need to graph. All right, so it goes from 0 to 2.5, from 0 to negative 2.5 or negative 3. So that's what I'm gonna do. That's my range. So I'm gonna go to 0. Okay, we have all the way to negative 3. So negative 3. Oh, okay, negative 3. Negative 3 is negative 14. So negative 3 comma 14. Sorry, negative 14. Okay, negative 2.5 is, oh no. Well, you know what, let's copy. Let's see if we can do this. Comma negative 10.25. Negative 2, comma negative 7. I am not gonna do any more points. I'm gonna go negative 1. Okay, is negative 2. 0 is 1. Okay, yes, I did it correct. 1 is 2. 2 is 1. All right, and that's it. Well, let's do one more. 3 is negative 2. So I'm not gonna grab the 0.5s unless I have to. So we have negative 3 comma negative 14. Negative 3, I don't have that in here, so I cannot graph that. Negative 2, I don't have that in here. Negative 1, yes I do, right here. So negative 1 goes with negative 2. So negative 1 comma negative 2 right here. Let me use the little marker. Negative 1 comma negative 2. Okay. The next one is 0 comma 1. 0 comma 1. Okay. 1 comma 2. 1 comma 2. 2 comma 1. 2 comma 1. 3 comma negative 2. 3 comma negative 2. And wow, it seems that I have a 4 here. So 4 is 4 comma negative 7. I don't have negative 7, so I'm just gonna leave it like that. And now look at what our parabola looks like. Okay. And now let's identify the vertex and the axis of symmetry. So these are the easy ones. Later on we're going to look at the difficult ones. So the axis of symmetry here. What is the axis of symmetry? Well, where does the line get divided in half? Right here. So the axis of symmetry is x equaling what? What does x equal? X equal to 1. See that? 1. Y is 100, x is still 1. Got it? The equation of x equal to a number is a vertical line that goes through wherever the x coordinate is. So this is x equal 1. How do I obtain the vertex? Right now it's visible at plain sight. Okay, the vertex happens at 1 comma 2, because after this the values start repeating. See that? 1, 1, negative 2, negative 2. So the vertex is 1, comma 2. And of course, look, the x-coordinate is 1. But anyways, let us do it again. The vertex is found by replacing the x with the value that you found on the axis of symmetry, on the on the AOS, axis of symmetry. So AOS, axis of symmetry, vertex, y equals, let me see, replace it, negative 1 square plus 2 times 1 plus 1. That's what it is. So let's see. 1 square is 1, but times negative 1. Plus 2 times 1 is 2. So that's it. Plus 1. Okay. Negative 1 plus 2 is 1. Plus 1, 2. So the y value when x is 1 is 2. Making our vertex 1, comma 2. That's how you find the vertex. The turning point. Vertex is the turning point. You say stop and then go back to the y values. Alright. I want to do 2 more and that's it, because we don't need all this. Let us examine this. So x equals negative 1/2 x. Well, what do I know about this behavior? The parabola is going to go like this. Okay? It's going to be opening up downwards. And from experience, let's see what when the coefficient of x squared is a fraction or a smaller number than either 1 or a larger number than negative 1. Let's see what happens. So let's see now. Enter y equals clear and negative alpha y equals to enter the fraction. If you don't have this calculator, you won't be able to enter fractions. So you're gonna have to put 1 over 2, like 1 divided by 2 in parentheses. 1 over 2, then press x square. Okay, and that's it. So now let's graph. Okay, now let me fix the window to what it was before. So the scale is 1. Scale is 1. Let's see what happens now. Okay, same shape. Now let's take a look at the table. Here we go with the table. I'm not gonna graph the funny points. Let's see what this graph goes. Okay, this graph also goes by 0.5. Let me write down the order pairs, starting at negative 4. Sorry. So negative 4, comma, negative 8. Okay. Negative 3, comma, negative 4.5. Negative 2, comma, negative 2. Negative 1, comma, negative 0.5. 0, comma, 0. 1, comma, negative 0.5. I'm kind of like not I'm gonna laugh at this because I started at negative 4, like I was counting negative 4 here. These are my x values, so all I had to do was look at here and look at here. Why am I going crazy? I should have started with negative 2, so sorry for my mistake, but this is where I'm gonna start. Okay, and I'm gonna go all the way to 4 if I need to. So now I hate this. So let's see now. 2, 3, and 4. So let's see. 2, comma, negative 2. 3, comma, negative 4.5. And 4, comma, negative 8. But I should have known the values start repeating. So yes, I'm so sorry, I made a mistake. These points don't count because the lowest value I have for x is -2. So you gotta look at your graph. You gotta be more careful. I'm sorry for my mistake. Let's continue with this. All right, let's graph them. -2, -2, -2, -2. Okay. Then -1, -0.5, -1, -0.5, 0, 0, 1, -0.5. Of course, this is the turning point. So now 1, -0.5, and 2, whatever that is, 2, -2. Then 3, what's 3, 3, -4.5. So 3, -4.5. I don't have that, so I will stop here. But now look at what the graph looks like. Oops, almost, no, I did miss the point, but I'm gonna make it up to you. Boom. Always remember to put arrowheads at the end, and always remember to label your graph. All right, so once again, the axis of symmetry is what divides the equation that divides the parabola in half. So here it will be 0, where x is 0, and the vertex, which you could see at plain sight, is 0, 0. So vertex, okay, axis of symmetry, vertex. Okay, and basically this is graphing parabolas. We talked about axis of symmetry. We talked about how to find the vertex. So that's it for graphing these little homies right here. All right then. Now, the vertex form of a parabola. No, we're not gonna do that yet. We're going to move on to factoring. We did factoring, but this time we're not just factoring. So let me give you a quick lesson on factoring. Let me get a piece of paper so I can explain to you how to do this. Okay, so look. Oh, okay, better? Sure. All right, look. Quadratic equations. We said that they always have x squared, correct? What does this thing start? Okay, right here. All right. So, x squared. That's how you know you have a quadratic equation. The standard form, so you better be writing this down. The standard form, standard form of a quadratic equation is ax squared plus bx plus c equal 0. Right? These a, b, and c are just numbers. Let me give you an example. We're not going to be dealing with that example. We're just going to be dealing with something else, okay? Or no, actually, let me give you this example. So we have, let's say, x squared plus 2x plus 1. So if you need to identify which one is a, b, and c. A is the coefficient of x squared, which in this case, it's a 1. B is the coefficient of x to the first power, okay, which in this case is 2. And c is the constant, the number that doesn't go with any letter. So there you have it. If you need more help, then rewind it and look at it again, because it will not change. Let me give you another example. 3x squared plus 100x minus 34. So equals 0. Remember, quadratic equations should always be equal to 0. If they're not, you have to make them equal to 0. That's the distinction. That's how you know. Okay, so A would be what? 3, because it's the coefficient of x squared. B, 100, and C, negative 34. Understand? Don't forget the sign. Don't leave it at home. All right then. Remember, you already had a video on how to factor. You need to revisit that video, which is part 4 on how do we pass the common core regions, and review it. Now we are ready to start with this. So, solving quadratic equations by factoring. Here we go. See? Okay, better. Yeah, you could see here. Okie dokie. Oh my God, so serious, Becker. Psh, caught you. Yes. Let's factor this. Oh wait, hold on a second. Is it equal to 0? Yes. Does it have a leading a leading exponent of 2? No. But wait. Remember what happens when you factor an expression? It looks like this, right? Correct. In other words, this is already factored. So then when we factor our polynomial, all we have to do is equal each of the factors to 0. Okay? If one of the factors is equal to 0, the whole thing is 0. So we're going to start with 3n. So 3n minus 2 equals 0. So let's solve this little tiny equation. So we're going to add 2 to both sides, correct? Please tell me you understand, because otherwise I'm going to die here. And now 3 is multiplying the n, so I'm going to divide by 3 on both sides. And n becomes 2 over 3. So when n is 2/3, whatever 2/3 is, then it becomes a solution to this. Everything, when you set it up to 0, then you are trying to find the solutions. 4n plus 1. So let's see, 4n plus 1. Do I have a different color marker so I could explain to my students how to do this? Okay. So this one, 4n plus 1. 4n plus 1 equal 0. So subtract 1 from both sides and you get 4n equals negative 1. You should know this by now if you watch the video on solving equations. Now we're going to divide by 4 on both sides. The idea behind dividing by 4 is to cancel this 4. 4 divided by 4 cancels out, right? I don't want to make a mess. And then this one becomes negative 1 over 4. And my friend, these are your solutions. But what does it mean to have solutions like that? Let me explain to you using the graphing calculator. Since I'm melting, this is like a melting pot. I'm using everything to explain to you. All right. So let us graph those points. Let us graph this. Parenthesis 3n. Sorry, 3n. Oh yeah, the calculator doesn't understand n, so we're going to put 3x, okay? 3x minus 2. Close parenthesis. And then 4x plus 1. Close parenthesis. Let's graph it. What do you think the shape is going to be? Of course, you saw the shape, right? It's a parabola. And now let's study the parabola a little more. 2/3 and 1/4. Let's see what 2/3 is. Let us understand what 2/3 is. 2/3 is point. In other words, 0.67, and 1/4 is 0.25. We know that, right? Sorry. Negative 0.25. Okay, so let us look at the graph again. And this time I'm going to concentrate on the graph. So I'm going to zoom in. Just this as much as I'm going to zoom in because I need these keys right here. So let's trace. These points right here, the 2/3 and the negative 0.25 are called the zeros. The zeros. And they represent all the values when y is 0. So let's take a look. When y is 0, let me see. I'm gonna press the key that reads zoom. I want to go down to where it says zoom fit, and I'm gonna press enter. Now you should have a better understanding of the parabola. See that? Nice. So this is the parabola. The points where the parabola hits the x-axis are the solutions. Just understand that. The solutions are also being called the roots. They are also called the x-intercepts. Well, duh, it touches the x-axis, so it's the x-intercept. So I want us to do something. Press second, and you see where it says trace? It also says calculate. So we are going to calculate the zeros. Okay? In other words, the solutions. So left bound, we want to go here on this side, okay? Right bound, we want to go around here. You don't want to go beyond that because it's gonna get confused. You want to know where in here does it touches the x-axis. So now you press enter, and then it says, do you want me to guess? Of course. And now if you look at it, what does it say? Let me make it better for you. Okay, here. See that? It says 0 and x is negative 0.25. Okay, now let's press again the calculate. So press second and then calculate. We want to calculate the other 0. Where is that? Well, it's asking you for the left boundary. So go right here, press enter, and now the right boundary, go a little more right here. Okay, because now you want to know where does the graph touch the x-axis and this side. Enter, guess, yes. And then look, it says 0 for y, of course, right here, and is 0.67 for x. So my friends, you just learn how to find the solutions to a parabola or to an equation using the calculator. We're gonna continue using the calculator, don't worry about it, and I'm sorry if I'm taking too long for this, but let's move on. All right, so this one is also in factor form. If I was to multiply, I get 5n squared, okay, then here I get 5n, here I get negative 1, so it's plus 4n minus 1. But anyways, it's already factored. So then 5n minus 1 equals 0. So add 1 to both sides, divide by 5, okay, and then the other factor, n plus 1 equals 0. N plus 1 equals 0. Here I don't even have to solve it. Why? Because what number plus 1 is 0? Negative 1, so n has to be negative 1. See that? Okay then. And now, to prove my point, let us graph this. So this is solving quadratic equations, okay? So let us graph this. You already know, so I don't have to explain to you how to use the calculator anymore. So we're just gonna have this screen over here. Okay, so y equals, I'm gonna get out of there, and then I'm going to actually see what the equation is. Okay, so it was parentheses 5n minus 1, 5x minus 1 in the calculator, right? And the other one, n plus 1, so x plus 1. Okay, and now graph. See, it's still in the zoom fit mode. So let us just trace it, because I want you to understand something. Let's see if we can get y equals 0. Nope, no, we couldn't get that. Not a problem. Then we're gonna have to go into second, calculate, and we know what we want to calculate. We want to calculate the zeros. Enter, and now left boundary. Well, let's go over here. Yeah, this is the left boundary. This is enough. Enter, and now it's gonna ask me for the right boundary, so I'm gonna go around here. Okay, because it says here, oh my god, how am I gonna do this? Here it says negative 1, so negative 1 should be a solution. So anyway, I'm gonna press enter, and then it says, you want me to guess? Yes. And look, when y is 0, x is negative 1. Got it? And then for the other one, you're gonna get 1/5. What is 1/5? I don't know. So let's see, 1 divided by 5 is 0.2. So when I press calculate 0, okay, I'm going for 0.2. So once again, my boundary is going to be around here. My other boundary is going to be around here. Okay, and I'm going to press enter. It says guess. Yes, and look, y equals 0 and x is 0.2. So there you have it. Now you understand how to find the zeros using the calculator. Now, is it always like that? Not really. Sometimes, look, you could just go into the table and find the values where y is 0. So let's see now. Oh, different no, this is it. So where 1, oh sorry, no wonder, here -1, -1, comma 0, you see that? And I don't have the table set to the right scale. So but if I want to, now that I know, I'm gonna press second table set and I'm gonna go by 0.2 for the sake of doing it, right? And now when I press the table, I'm gonna get that. So let us go on to y0. So let's see now, 2.1, wait, -2.1. Okay, wait, why does it go? You know what, let me set it up again, and this time I'm gonna ask it, table start at -2. Okay, now this should work. Second table. Okay, I should have 0.2 here. Yes, look, -2, comma 0. I'm sorry it took too long, but I'm learning as well as you are with this new technology available. All right, let's move on to the next one. And now, guys, you know how to do this. This is the last time when I use the calculator. You already know how to do it. Number 5. Okay, how to solve by factoring. So the first thing I'm gonna do is, it doesn't matter what you do, how you do it, how you factor it. What matters is that you do it right. Look, every quadratic equation, quadratic, x1 of 2, is supposed to be equal to 0. Is this equal to 0? No. So I have to make one side equal to 0. If the square term is already positive, then don't trouble it. Trouble everything else except that. So let's see now. 33k. 33k is on the other side. How do I make this 33k disappear? Subtract 33k from both sides. Okay? Subtract it. Okay. Now, when you subtract it from one side from the other, right? Please do not tell me that you're gonna combine 3k squared with -3k. They're not like terms. This is k squared and this is k. So if you were thinking about it, forget it. So let me write the new equation. 3k squared, okay, minus 33k plus 72 equal 0. There you have it. Now I am going to factor. So the first thing I'm gonna do is I'm gonna see if there is a greatest common factor. It's usually, sometimes the case. So I know I can divide this by 3. I know I can divide this by 3. I don't know if I can divide 72 by 3. So what you're gonna do is you're gonna put it in the calculator and you're gonna divide by 3 and see if you can. Then you're gonna find out that you can. So you take out the 3, okay? Open the parentheses. If you were to divide everything by 3, what do you get? K squared minus 11k, okay, plus 24. Yes, 72 divided by 3 is 24. And that equals 0. Now you're going to factor this expression. So you open the little parenthesis. Okay. Factors of k squared, k and k. Factors of 24, 8 and 3. Yeah, it works. 8 and 3. I need a negative 11, so when I do the smiley face, which you already know about it, this becomes 3k and 8k. 3k and 8k. How can I get negative 11? Add them up and make them both negative, or make them both negative and add them up. Am I forgetting something? Yes, this other factor. Okay, now what you're gonna do is you're gonna equal each of these factors to 0. What? Yes, for example, 3 equal to 0, k minus 8 equal to 0, and k minus 3 equal to 0. And now let's find our solutions. Can 3 ever be equal to 0? No. So 3 is not a solution. Can k minus 8 equals 0? So all you have to do is add 8 to both sides, and k becomes 8. Or just ask yourself, what number minus 8 is 0? 8. Okay. K minus 3 equals 0. What number minus 3 is 0? 3. Okay. Now these are nice numbers. So we could actually, I'm gonna use the calculator for this one. So take the calculator, look, 8 and 3, right? Those are the solutions. So I'm going to graph the equation that was given to me. So y equals, okay, then 3x squared, because the calculator doesn't understand k. Remember, it has to be solved for 0. So I have to go to this one. There you go. Minus 33k or 33x plus 72. Okay. Now I'm going to graph. All right. I'm going to get rid of this because we don't need it anymore. So zoom box, zoom in. Actually, no. All I have to go is go to the table. Minimum 10, and now the minimum for y is gonna be, is usually the default is negative 10. The maximum is 10. Okay, the scale is 1. Let's take a look at our parabola now. Right, there you go. And now at plain sight, without calculating anything, look at the x-intercepts. 1, 2, 3. 3, right? And what's the other one? 1, 2, 3, 4, 5, 6, 7, 8. See them? Good. If you don't see them, then let's go to the table. Second graph, and look at, and I'm gonna change the table set again. I'm gonna go in increments of 1, and you're gonna start at negative 4. I really don't care. Okay. Let's take a look at the table now. So when x is 3, y is 0. And when x is 8, y is 0. We found our solutions. Remember, those are the solutions. Okay, let's do another one. 7b squared minus 42 equals negative 35b. Is this equation solved for y? No, it's not. So I need to solve this equation for y. And I just made a mistake. You're not solving for y. You're solving for 0. You're making one side equal 0. What I'm trying to say is that when I say solve it for y, is that when you're going to put this type of equations on the calculator, you replace the 0 with the y. All right? All right, cool then. So let us do this. I need to make one side equal to 0, so I am going to add 35b to both sides. At this point, it doesn't make sense for me to explain from scratch. If we can do this, so plus 35b minus 42. Okay. Now ask yourself, do I have a greatest common factor? Well, can I divide by 7? Yes. Can I divide by 7? Yes. Can I divide by 7? Yes. So take out the 7, and what do you have left? B squared plus 35, 7 times 5, okay. And 42, 7 times 6. Equal what? 0. Equal what? 0. Okay. And as I said before, when you're gonna graph, you just replace the 0 with a y and you put it on the calculator. All right. Time for me to start factoring. So how do I factor this? Yeah, you thought it was 3 and 2, right? If you try 3 and 2, when you do the smiley face, it doesn't work. I just did it in my brain. When I do the smiley face, I get 1v and 6v. I need positive 5v, so I'm going to make this positive and this negative. And when I multiply them, I get back negative 6v. Okay. Now, you got to make each factor equal to 0. So, 7 is a factor. V plus 6 is a factor. V minus 1 is a factor. Now you solve for the letter. 7 will never be equal to 0, so we reject this choice. What number plus 6 is 0? Or subtract 6 from both sides. Add 1 to both sides. And voila. Okay, another one. Sure. Here. Is the equation solved for 0? Or is the equation 0 equal to 0? No, right? So we're gonna make it equal to 0. Let's see, I'm gonna need extra space, so I don't have a problem with that. I'll do this. Hey, don't get blurry. My name's Blurry Face and I care what you think. Gucci? Okay, let me see. Yay, okay. Solve for 0. Look at this. The coefficient of b squared, the square term, is negative. So you know what? I want it positive. And how do I make it positive? Well, remember something. You gotta make one side equal to 0. So it's easy to make the side that has if you have a negative something square, it's easy to make that side 0 than to the other. But wait, I also have negative 3b squared in this side. So if I make this 0, I will have to add 3x squared. And if I add 3x squared to negative 2, I'm going to end up with a positive square value. It works. Okay then. So I'm going to make this side equal to 0. Oh look, a black mamba. I'm going to touch it. Poisonous. So plus 3v squared. Okay, write that down. Plus 3v squared minus 6v. Okay? Well, you know what? Let's do it. That's a square, by the way. Sorry, it doesn't look. Okay? Okay, and what you do to one side, you do to the other. So the 3v squared goes here. And the negative 6v goes right here. Okay? So now, negative 2v squared plus 3v squared is v squared. Negative 1v minus 6v is negative 7v. 12 didn't do anything to 12, so plus 12 equal to, see, I added the opposite, so now this is 0. Let's factor now. I know there is no greatest common factor because the coefficient of the square term is 1. So, VV. And now, factors of 12, 4 and 3, right? Negative 4, negative 3 equals 0. You already know how to factor. That's why I'm not really like explaining much. And now, what number minus 4 is 0? Positive 4. What number minus 3 is 0? Positive 3. Okay? And that, my friends, is how you factor using the, that is how you solve quadratic equations by factoring. So I'm going to ask you to please write the following down and solve them. Remember, you can always use the calculator to confirm your answer. See, this is already in factor form, so that's why I just wrote it like that. Now I'll try this one. Yeah, can you explain to me what I actually did? Correct. I need to make one side equal to 0. The n squared is already positive. So I added 9n to both sides and I added 18 to both sides, and that's what I got. After a while, it becomes automatic what you're doing. So you won't be thinking about, oh, I have to add 4k to both sides. No, just write down 4k, you see? What? Wait, why did I get the same answer twice? Oh my god. I know why. Because this, my friend, is a PST. Do you know what that is? Exactly. Perfect square trinomial. The same number that got squared gets doubled over here. Oh, okay, got it. Yeah, you thought I was gonna write 4 and 4, right? Okay, so you finish it. You should be able to do it. All right. Do I have another piece of paper? That's funny. I don't remember. Oh gosh. Okay. Wait. Do I have another piece of paper? All right. Oh my lord. Where is that piece of paper? Oh, okay, right here. All right. Continue with the rest. Okay, I'm just gonna help you, but I'm not gonna be giving you any directions. You already know what's going on. Okay, here we go. You're doing it, remember? You have me on pause. Okay, now I help you here, and I'm giving you what the roots, the x-intercepts, okay, or the solutions are. But come on, it's your job now to fill in the factoring. What is this, Becker? Hello, it's negative 65. Negative. Holy dawn. You should know what I just did. Okay, I really don't know. I know there's a common factor, but I don't know which one. So I'm gonna try. I know I can divide all of them by 2, but let me see if I can divide all of them by 4. I know 16 I can. I don't know about 114. Nope. How about, oh, of course, 14 cannot be divided by 4, so I'll stop that. By 7 I cannot divide that. So I guess it's 2. All right. Wait, can I divide by 8? No, I cannot divide this by 8. So 2 it is. What is 114 divided by 2? Okay. And now you're telling me that I gotta factor this the way it is? Alright, whatever. So then, you know what? Nah. Remember something. When you factor, you could use the AC method if you want to find the factors, or you could factor by trial and error, which basically, I mean, it works. So try it, because really I also have to try, because I have no idea what the answer is. So how do I try that? Let me see. So the answer should be I got it, I think. So I'm gonna try 8n and n, factors of 8n squared. And factors of 7, if I put the 7 here, I'm gonna end up 7 and 1. So I'm gonna end up with 8n and 7n. but if I put the 1 in here and the 7 here, then I'm gonna get 56 and 157. Now what the sign should be, negative, both of them negative, so I can get negative 57 when I add them, and I get positive 7 when I multiply. And now I'm not gonna give you the answers, you gotta equal each of the factors to 0. And let's do the last one, okay? So with this you should master solving quadratic equations by factorization. For the last one, I'm just gonna leave you with the answers. A, right? Got it? Okay. And just as an 8, remember you gotta subtract 7 and you gotta add 40A to both sides. Make it like that. And this covers graphing quadratic equations in standard form, okay? And also solving quadratic equations by factoring. And the next one, we're gonna continue with the quadratics. We're gonna see more methods on solving quadratic equations, and then we're gonna go back to our JMAP packet of regents questions, okay? But at least you got that knowledge. All right.